Tech companies are locked in an arms race to build the largest digital brains possible. They are aggressively expanding the context window, the finite, short-term working memory where an AI processes your information. The prevailing industry logic suggests that since these models are supercomputers, feeding them entire textbooks, codebases, and years of chat logs will result in perfect, comprehensive answers. But as users push the limits of these data dumps, the output degrades. Instead of becoming smarter, the AI begins making highly confident factual errors. This shows up in business as a silent reliability failure. An AI assistant might cite a company travel policy from 2019 while completely ignoring the 2024 update, simply because both documents were included in the same prompt. Or in a long conversation, the bot might abruptly forget a strict legal instruction given just 20 minutes earlier. Because AI computing costs are calculated by the token, a unit of text roughly equivalent to a single syllable, organizations are actively paying higher fees to generate these inferior, hallucinated answers. Overloading the system doesn't cause a spectacular crash. It creates a structural erosion of reliability, known as context rot. The context window is the finite, geometric architecture of an AI's short-term working memory. When you provide a clear, one-page brief, the model operates in a clean, navigable space. The model processes this using an attention mechanism, which mathematically calculates the relationship and relevance between every single piece of information. With a small dataset, the connections are direct and strong. But if you dump in 5,000 pages of mixed data, that physical space becomes congested. The attention mechanism tries to connect every single data point to every other data point. The web of relationships becomes so dense that distinguishing the relevant signal is mathematically impossible. The AI hasn't lost intelligence. Its attention has simply diluted. It hallucinates because it can no longer determine which facts are most important to the task. In the architecture of AI memory, infinite capacity results in a total collapse in focus. Data scientists have mapped the exact statistical pattern of this collapse, a phenomenon they call lost in the middle. This graph tracks the model's accuracy across a massive prompt. The AI maintains near-perfect recall for the data placed at the very beginning of the block. Recall is equally accurate for the instructions provided at the very end. However, recall performance drops off a cliff for the massive chunk of data residing in the center. Critical facts or specific instructions buried in this middle section are statistically likely to be ignored or permanently forgotten by the model during processing. Overloading an AI doesn't create omniscience. It creates a rotting blind spot in the center of your data. Organizations cannot fix context rot simply by buying a more expensive AI model. The mathematical limits of the attention mechanism apply to even the largest systems. Solving the problem requires a shift from prompt engineering to context engineering, operating on the principle that we must curate the information we provide, rather than dumping it all in at once. This is the role of a RAG system, or Retrieval Augmented Generation. Instead of the AI reading an entire manual, the RAG system fetches only the single relevant paragraph needed to answer a specific question, keeping the context window pristine. Efficiency also comes from aggressive pruning. This strategy involves forcefully resetting the context and summarizing old conversation history to wipe away accumulated noise. Finally, strict data hygiene ensures the AI doesn't have to choose between conflicting truths. Deleting old drafts prevents the model from weighing outdated information against the final version. To get a return on investment from AI, we have to move past the idea that more data equals better answers. Reliability is achieved by engineering exactly what the machine should ignore.